Oh, yo, everybody. I hope all's well with you. I'm going to be going over something here in this video. This has to do with refraction and actually why we can't get refraction to help the globe. So when we look out over water, tests for curvature need to be done over water because both models claim that water is level at the surface. One says flat level, the other says center of mass curve level. The distance from the center of mass is equal. Well, you know, oblate spheroid allowed distortion in distance or difference in distance, but the globe says that all water at the surface is the same distance from the center of mass of the center of the earth, and so water is level. So both models claim that water is level. Now when we look out and do tests in reality, what do we see?
When visibility is high without miraging, we see way too far, in total contradiction to the globe model. Because of these repeatable observations that anyone can perform, the only counterclaim the globe propagandist has is refraction. As though refraction has this fairy tale property that inexplicably removes all evidence of giant bulges of Earth curvature, the globe claim is patently false. As shown here and in countless examples, refraction is real. It compresses, it stretches, it distorts, it obscures and mirages. You can see it with your own eyes. But the globe propagandists have hijacked the term refraction and took this observable reality and deceptively changed refraction into an imaginary Earth curvature removing device. In my last video, I shared this footage proving the globe horizon was supposed to be closer than 2.3 miles, but the horizon is many miles beyond 11.2 miles. The globe bulge was supposed to be blocking 25 feet of the first turbine and blocking 53 feet of the furthest turbine. Instead, you can see the base of the turbines getting perspectively higher instead of sinking below the supposed Earth bulge as the ball would require. The globe propagandist's only counterclaim is that refraction caused the Earth bulge to disappear without a trace and then reappear miles beyond 11.2 miles, all without affecting the 6 turbines in between. I hope you already see that the refraction claim is without merit. I filmed this footage as my wife walked from the top of the beach all the way to the water's edge, where she placed a 4-foot mirror into the water 6.3 miles away. I filmed her the entire way, but the globe curvature was supposed to be hiding 12 feet. But look at this still from the video. There is absolutely no distortion of the distant shore, but this 12 feet here should be behind the curvature of the Earth, like this. Did that 12 feet hop the curvature without causing a cascade of distortion? If 12 feet jumped the curvature, wouldn't it then overlap the 12 feet above it, causing manifest distortion? Are we to believe that every inch up to at least 100 feet uniformly arced perfectly over the curvature to present this flat, non-distorted distant shore? In this example I shared in my first fact video 1, the distant shore was 21.03 miles away. You can see the non-distorted distant shore. 223 feet should have been hidden behind the Earth curvature, but none of it is. If 223 feet hopped over the curvature, where is the manifest distortion, as that 223 feet would then overlap the 223 feet above it? There is zero evidence of this refraction distortion, and the mountain behind evinces the same. At the same spot, I then filmed my friend's laser that should have been 218 feet below the horizon. Not only did I film the bright laser source, but I also filmed the reflection of the laser source on the water, which would have appeared somewhere around here on a ball. Think about that reflection on the water. Bear in mind that the reflection would have been angled away from my point of view, but the giant bulge supposedly just disappeared, and everything in the distance wrapped around the Earth curvature perfectly to keep the image intact. Furthermore, if that nonsensical refraction event happened, why didn't the bulge itself jump up and still continue to block the laser? How did refraction affect everything but the closer giant bulge, but instead made the bulge disappear? From Grota 1 from a frozen lake in Manitoba, Canada. I strongly encourage everyone to head over to his channel and subscribe to show your support, because he obviously went to a lot of effort for truth here. For this curvature test, Grota 1 essentially set 4 lights at around 1 foot above the water and ice. He set up his camera at about 8 miles away from the furthest light and 5 miles away from the closest light. The lights were spread out at about a mile apart. At each location, Grota 1 drilled down to the water just to confirm that he wasn't on some irregular ice formation, and to also ensure that his test was on a level surface. The furthest light from the camera was the red light at 8 miles from the camera. The blue light was at about 7 miles, the yellow was at 6 miles, and the orange light was the closest one at 5 miles away from the camera. You should definitely watch his video where he goes into much more detail, but here he is sitting in his truck at a distance of 8 miles from the red light. Notice that the lights are all on the same flat plane. There is no earth bulge and no physical globe horizon. Next, Grota 1 lowered his camera to only 12 7/8 inches above the surface. At that small elevation, the globe horizon would have to be closer than 1.27 miles, and the furthest light, the red one, should have been 29 feet below the horizon. That's taking into account the 1 foot height of the light. Notice how the lights are all on the same flat plane. There's absolutely no supposed bulge here. And if there is no curvature on that frozen lake, then there is no earth curvature anywhere. Look at the red light. That light should be 29 feet below the horizon. Finally, Grota 1 brought his camera down even lower to just 5 7/8 inches off of the ice. At this very low elevation, the red light would have to be a whopping 33 feet below the horizon. That's 34 feet minus the 1 foot height of the laser. Without question, the globe fails again. Furthermore, under the official model, the globe horizon would have to be closer than a mere 0.86 miles. There is no globe physical curve here, blocking your view. As Grota 1 demonstrated on this frozen lake, regardless of the conditions, the Earth is observably, testably, repeatedly, and measurably.
We see two different things here. So this test is done in cold weather here, and we see 4 dots in a straight line, linear, planar, horizontal, parallel with the horizon. These 4 dots are in a line. We see that in cold air. We also see on the other end of the air, we see a laser beam going across water from one observer to the other, and we see the actual source of the beam, not even just the beam itself, but the source, seeing the actual light source. And so the thing is oh, oops, I just turned the light on here. So in chemistry, at least, when we are doing refractive measurements and in the lab, there's something called standard conditions, which is 20 degrees centigrade, and that is like the temperature that the refractive indexes are measured. So each element, each molecule has a different refractive index, and that measured official accepted standard is measured at 20 degrees. And so in the cold weather, you subtract 0.0004 from your measured refractive index for each 1 degree below 20 degrees that you go. So if you measured 1.5567 at 20 and you go down to 19 degrees, you would subtract 0.0004 and you would get 0.5563. So your refractive index would go down. Or if you add a degree for each 1 degree above 20 degrees, you go up in your refractive index. And so that would go from 0.5567 to 0.55 or what did I say, 1.55? 1.5571, because you're adding to the 67 plus 4 is 71, so 5571. So you're going to add or subtract whether you're in hot or cold. Now, what this means is that here you have a light source, which would be below physical geometric Earth curve, because the Earth, if it were a globe, would physically have an observer at a height, and then from that observer height looking out, you would get this drop in the Earth, because a ball has constant curvature. So if we go like, if you look at a ball, there's continuous curvature. So if you're standing at the very top of the ball and you go out, there's curve. There's going to be this drop, this geometric drop. And so we know the dimensions of the Earth, and so we can calculate what the curvature should be at each distance. And so you have this object down here, this light source, and now this I drew in green to match the laser beam, but this could also be one of these light sources at 5, 6, 7, 8 miles out. And so you have this light source that is below the observer. And so now, depending on which way, because I've heard both about cold air and hot air, bending light up or bending light down. Here's the thing though, is that they're different. You're either gonna, if you take the A path, you have hot air bending the light up. So okay, maybe the hot air will allow this light source to bend up and go over the curvature and reach the observer eye. However, if you take the A path, you're going to take this light source and bend the light down. So you're not going to see A in the cold air, because it would bend down and it's below you, and you cannot start below, bend down, and get up. So you would only see one of these depending on the temperature, or if the cold air makes the light bend upward, then the hot air makes the light bend downward. So you wouldn't see the hot air observation, and we can see light source in both temperatures to cover both sides of light bending due to the atmospheric refraction from the water vapor and other things. And so you do have this cold air, the light goes, the Earth would be bending down, and in the hot air the Earth would be bending down. And so you're either going to see you're not going to see the light source, and the beam is going to go over your head, or you're not going to see any of these lights because they are hidden behind curvature. And we actually, these do have definite direction, because if you have the sun coming in from one way, that means that the sunlight is going to be going down away. So the Earth is dropping down and away from wherever you are at all times. Every other direction going towards your horizon is bending down, moving away from you. So you cannot go up here in cold air and up here in hot air. And so this is actually, I believe, an impossibility for the globe, if I'm not mistaken, because you cannot have a light source go up and down and reach the same observer, especially when that lower path is going to be blocked by physical geometric Earth curve, the physical curvature of the Earth. And I would also like to point out that this light here at 5 miles is only 1 foot high off the ground, and the observer height is less than a foot. So this camera is actually angled up to see this light, because we know that the Earth is planar. But we, at 5 miles, we're supposed to be able to say refraction can bring this light alone, just this 5 mile light, back into view to the observer. But then a ship, which it would be 4 feet high, at 3 miles is enough to hide behind curvature, according to our science promoters.
The simple to the slightly more complicated. One of the things you can see yourself with a pair of binoculars is if you actually go out to a lake and there are boats on that lake, the farther away a boat is, the more the bottom of the boat will disappear and you'll basically just see the mast of the boat. And as a boat goes farther and farther away, the last thing you will see is the very top of the mast of that boat. And that's because the boat is actually going over the horizon that's curved. And that means that as it goes farther and farther away, you see less and less of the bottom of it and more of the top of that. You can see that with binoculars, by an ocean, by a lake. It's really easy. That wouldn't happen if the Earth.
Hi there everyone. We'd like to show you a little experiment we did in our own living room. This observation is similar to the pebbles in the pond observation, but conducted on an even smaller scale. The lighting wasn't the best for this observation and is something we will improve upon the next time. But by the end of the video, you will definitely witness the mirage effect, which prohibits some of the light from the objects to arrive to the viewer. This all took place within 20 feet in our living room. The objects were placed about 18 feet from the viewing location, and we were viewing from approximately 1 1/4 inches above the floor. We used a few small, thin, household items to be our distant objects. The temperature at the surface was about 52 degrees, and it was about 88 degrees a few feet from the surface when the mirage was at its most apparent. Here are the objects from the viewer's perspective. And here, we open our patio door to let a layer of cold air into the house. Soon after, the white guitar pick at the bottom begins to disappear. Now, we close the door, and the white pick quickly comes back into view. Here are some time lapses that show just how much the mirage affects the light that travels from the objects to the viewer. For this last observation, we used the RC car to drive this little plastic piece into the mirage. The room was about 70 degrees, and we again opened the patio to the cold air below the curtains. Here is a time lapse. Here, we shut the door, and after the air in the room settles, the light from the object is able to fully arrive to the viewer. And here are a few more clips of the object entering the mirage and appearing to sink below the horizon. And finally, here, we raise and lower our viewing height while the object sits in the mirage. The object comes into full view as we raise the camera to a few inches, and then disappears as we return to the floor.
So, and down here we do have laser beams, and this has been repeated many times: hot air, cold air, various distances. People see light beam sources, laser beam sources, reflections. People bring mirrors and bounce the light from the sun. Also, water makes a perfect mirror. If you look at still water, that only happens without distortion in the reflection if it's a planar flat surface. Concave and convex lenses will distort images, reflections, and so that's another thing, a little extra. But people, we see too far, and this is what they mean. And refraction cannot save the globe from seeing too far, because if light bends up in one temperature, then it has to bend down in the other, or vice versa. So whichever one you want to say, because that's chemistry, that's what we learn in chemistry. I learned that, and it's what anyone will learn if you do refractive index measurements in a chemistry lab. So this is impossible. You cannot both go up and down. So, and this is what we observe. Straight, level, flat, horizontal, planar characteristic, matches bridge diagrams, matches water, ocean cable laying diagrams, tunnel diagrams. All of that matches this feature and this feature as well, with level water over lakes and oceans. All right, thank y'all for watching this. Peace be with you all in Jesus' mighty name.